All right, I'd like to start out with problem number 1 on the classwork, and this is just focusing on how do we actually calculate the confidence interval, those two numbers that we use, the lower end of the interval and the upper end of the interval. So I have 3 examples for you here to work on, and I'll do the first one with you and then give you a chance to pause the video and try these other 2. So we're doing x bar plus or minus z star sigma over root n. So I know that x bar is 20, that it's plus or minus z star. To get my z star, I look at my confidence level. My confidence level is 95%. So if I go up here, 95% tells me that z star is 1.96. So I'll write that down. And then I need sigma, which is 3, divided by the square root of n, which is 36. Yeah, I'm going to put that in my calculator. So I have 20 minus 1.96 times 3 divided by the square root of 36. Got that in there. That gives me 1902. That's the lower number. So this subtraction will always give you that lower number. And then addition will give me the upper number. Now, if you're using a graphing calculator, you don't have to retype this whole thing. You can hit the second button. And then down here where the enter is, it says entry above that. If you push this, it gives you the exact same thing you typed in, and you can use your arrow key to go back and swap that minus sign with a plus sign, and then hit enter. And so then we'll get our upper bound. If you're not using a graphing calculator, I'm sorry, I don't have a nice trick for you. You can just retype that. If you are on a cell phone and using the calculator on your cell phone, my recommendation is not to use the cell phone calculator because the square root thing on those is a little goofy. I would actually just go straight to Google and type what I typed in here in Google. You could type, instead of that square root sign, you could just type SQRT and then do parentheses and put the 36 in there, and that should work, and that will get you the same number. But regardless, if you're not doing it on a calculator, however you're doing it, just make sure that you're getting these same numbers. All right, I'm going to go ahead and work these other 2. You're welcome to pause the video and try them on your own and then see if you get the same thing I do, or you're welcome to work them along with me. Either way is fine. The second one, so x bar is 30. Plus or minus, I need a z star that goes with 90%. So 90% gets paired with 1.645. And then sigma is 4 divided by the square root of 25. And I will put that in my calculator. So 30 minus 1.645 times 4 divided by the square root of 25. 28.684. And then I will redo that calculation with the plus sign instead. And that'll give me the upper end of the interval, so 31.316. And then this last one is 50 plus or minus. Then I need a z star that goes with the 99% level. So 99% is 2.576. And that'll be times, my standard deviation is 5 over the square root of 16. So put that in the calculator. So you get 50 minus 2.576 times 5 divided by the square root of 16. So that gives me 46.78. And then the plus side of that is going to give me 53.22. All right, so hopefully that agrees with what you got. And we're going to go ahead and take a look at doing our first whole process of a confidence interval. All right, so we have a question about C3PO. C3PO collects all sorts of information. In a sample of 50 randomly selected hyperspace jumps, it took an average of 42 seconds to check the coordinates and make the jump into hyperspace. The population standard deviation for this important task is known to be about 5 seconds. Find a 95% confidence interval for the mean time it takes to make the jump to hyperspace. All right, so our first part of this for panic, P, is a statement about what we're doing, what our parameter statement is. So we're doing a 95% confidence interval for mean time to jump to hyperspace. Right? Doesn't need to be a complete sentence, but just something quick and easy enough to remind you of what you're doing when you get down to writing your conclusion. All right, the A is for our assumptions. So simple random sample. We come back up here. We've got randomly selected, so that's good. The next one is it either needs to be normally distributed or we need a large enough sample. So one of those two. And what we know is that our sample size is 50, which means it's certainly large enough. So what I'm going to do is I'm going to write down n equals 50. And I'm going to circle that I use the large condition. So you need to indicate which one of these two you're using. And if you use the large one, then you need to write down what the sample size was. Okay, it's an indication that you understand that you need 30 or more. And then the last one is, do we know our population standard deviation, which is sigma? And in this case, it says the population standard deviation is 5. So there we go. Got that. So those are our three conditions or assumptions. So we're done with that part. The N is the name of this. This is a one mean Z interval. Right. Then we need to calculate this interval. So this is going to be X bar plus or minus Z star sigma over the square root of N. So I've already written down N and sigma. So I need to figure out what X bar and Z star are. So X bar is, let's see, it took an average of 42 seconds for these 50 randomly selected jumps. X bar is 42, and Z star is tied to this 95%. So at a 95% level, Z star is 1.96. All right, so I have all the numbers I need. So my interval is going to be 42 plus or minus 1.96 times 5 over the square root of 50. Okay, so I'm going to put this into my calculator here. 42 minus, and I always do the minus first because that gives me the smaller number, which is the first number I want to list. So minus 1.96 times 5 divided by the square root of 50. It gives me 40.61. And then I'll do the same thing, but with a plus. And with a plus, I get 43.39. Right, so that gives me the I for my interval. And then that just leaves me with writing my conclusion. Now the nice thing about this is since I already wrote this up here, I'm really just combining this piece with this piece here and I'm done. I don't have to go back and reread this to figure out what I need to state as my conclusion. So we are 95% confident. The true mean time to jump to hyperspace if only I can spell, is between 40.61 and 43.39 seconds. So make sure that you get some units on there. That interval usually has some units. All right, so there we go with that. Okay. Okay, I want to show you one more thing. In terms of calculating this interval, I do have a spreadsheet for you. Normally we would make this spreadsheet in class together, but just the end of the semester is short, so I'm just going to give you this spreadsheet, but you also have this available to use. So let me show you how this would work with the problem we just did, the hyperspace jumps. So my confidence level is a 95% confidence level, so I do put that in as a decimal. I put in my sample mean X bar, which is 42. My population standard deviation was a 5, and then my sample size was 50. When I put that in, here's my lower bound is 40.61, which is what we got. And then my upper bound is 40.385, which I had rounded to 43.39, so same thing. So this is another way of getting that interval if you would rather use this spreadsheet. This is available on Blackboard as well. Okay, so a couple of different options there for calculating that interval.